Topic 13. Vectors. Forms of vectors. Today we will be learning to use vectors in any form and know and use position vectors and unit vectors. Key terms. Scalar quantity, a quantity with only magnitude, strength or size. Vector quantity, a quantity with both magnitude and direction. Length of A, the length of A. Ignore this definition, it is not true. Given an example of a vector, a plane. The scalar quantity is speed, and the vector quantity is velocity. So when represented by an arrow, the length of the arrow is the size, and the arrowhead is the direction. Classifying vectors. Length. The vector here can be classed as OA, with an arrow over the top, a bold A, most frequently used in textbooks, and an arrow over the A, which you can use in your workings out. The magnitude may be classed as length of OA, with an arrow over the top, capital OA, length of A in bold, length of A unbolded with an arrow over the top. We can say that this vector OA originates at O and terminates at B, terminates at A, and is also the position vector of A relative to O. Base unit vectors. So it's any vector which has a length of 1 unit. I represents the direction of the unit in x direction. So 1, 0 would be in the positive, and minus 1, 0 would be in the negative. Negative be going left and positive going right. J is the base unit vector in the positive or negative y direction. So again, 0, 1 being right 1, and 0, minus 1 being left 1, being down 1. Sorry, positive is up, negative is down. Okay? So the Cartesian plane. So it's essentially just a graph on which each point is shown relative to the y and x axes. The 0, 0 point is also shown. It's called the origin. So take the point P, 2, 5. To get from O to P, the vector OP, you go across 2 units right in the x direction, and then you go up 5 units in the positive y direction. We can therefore say that the vector from O to P is 2, 5. So standard basis. This uses the base units I and j, remember. So the position vector OP, the point of the point P, x, y, and the point O, 0, 0, OP is equal to xy, which is called the component form. The position vector OP is also equal to xi add yj, where I is the base unit vector in the x direction, and j is the base unit vector in the y direction. And x and y are the points x and y. So you're essentially multiplying vectors by vectors, which we will kind of look at in the next section. So, for example, P2, 5, x would be 2 and y would be 5, so OP would be equal to 2i add 5j. You're moving 2 places right along x and 5 places up along y. Position vectors, so consider a vector from origin O to point A. We can also call it A. We classify this vector as a position vector of point A. It's a position vector of A relative to O. It's the, okay. 0 vectors. As the name suggests, it's a vector of length 0. It's the only vector with no direction. So you can represent it as 0, 0, or just 0 with an arrow across the top. So vector equality. Vector equality is kind of true for two vectors if they both have the same magnitude and direction, or x and y components. They can be shown as parallel and equal in length, and they're only being translations of each other. Okay? Negative vectors. So as you can see in the diagram here, we're going from point A to point B, and also from point B to point A. So they have equal length for opposite directions, so vector equality. So we can thus say that BA is the negative of AB and vice versa. So we can thus write BA is equal to minus AB, and and BA is equal to negative, so BA is equal to negative AB, and AB is equal to negative BA, correct? So if AB is equal to xy, then minus AB is equal to minus x minus y. So magnitude. Consider A is equal to 2, 3, or 2i at 3j. The magnitude length of A is represented by the length of A, which has got two lines on either side of it. So we use Pythagoras to solve this. So if A is equal to A1, A2, or A1i at A2j, the magnitude / length of A is the length of A is equal to root or A1 squared add A2 squared. And A1 and A2 are so A1 and A2 here are 2 and 3 respectively. So we input it into the formula. So 2 squared add 3 squared is equal to 4 add 9, which is equal to 13. So A is root 13, and it has to be positive because A cannot equal a negative number because it's a magnitude.